Okay. You got any questions before we get started with anything? Okay, cool. So we have done, as a matter of fact, I can share this. Excuse me. So we have done all of this first block as far as lecture is concerned, and then we did 10-1 through 10-4 last class. So we'll probably knock out 5 and 6 today. And then next class, Wednesday, probably be like a review day, you know, see if you guys have any questions generated or anything like that. Oh, let me do this. All right. So yeah. So next class, so we'll do 5, 6, 5, 5, 10, 5, and 10, 6 today. And then we'll be done with as far as lecture is concerned, with the first 2 blocks of content. And so, like I said, next class, which is Wednesday, probably just be a review day. See if you guys have any questions. But I need to map it out. I'm trying not to do anything new. I'm trying to give you guys a chance to get in there and finish the stuff up. But since we're in chapter 10, we might as well just finish it, and then we'll go from there on chapter 10 on Wednesday. Be a little bit of a review day. And pretty much a free day for you guys to do what you want to do. So, all right. Oh yeah, 10-6 was functions. Yep. All right, so 10-5, equations of lines. And we talked about the slope-intercept form, some already. Y equal to mx plus b. The number in front of x is your slope, that's m. And then b is your y-intercept. So they could give you an exercise like this, where they ask you to determine the slope and the y-intercept. And for A, I can leave it red. They give us y equal to 3/5 x minus 2. And I believe we talked about this last class. What's sitting in front of x is your slope, and then the other number is your y-intercept. So if they say determine slope and the y-intercept, that's all they ask you to do. Whatever number is attached to the x is your slope, the other number is your y-intercept. Then in B, we have 5x plus 9y equal to 11. So that one, we're going to have to solve it for y to put it in this format right here. Have y on one side of the equation by itself. Once you've done that, then you'll be able to pick out what is the slope and what is the y-intercept. So we have 5x plus 9y equal to 11. So we need to get the x term to the other side. So we subtract 5x from both sides. And that will give us 9y equal to negative 5x plus 11. Then to get the 9 off of y, we would divide both sides by 9. And then over here, you see we have y equal to negative 5x over 9 plus 11 over 9. So that 9 has to go into each term on the right side of the equation. And once you've done that, simplify it as much as possible. Negative 5/9 will be our slope, and 11/9 will be our y-intercept. All right, anybody? Okay, so here it says find the equation of the line with the y-intercept of 0, -3, and slope of 1/4. All right, so we have our y-intercept and we have our slope. So we have the slope intercept form. We have y equal to mx plus b. We can just plug in our values for the missing pieces. So 1/4 for m, and then that -3, since it's a y-intercept, all it is that -3. You see x is 0. Remember, for all y-intercepts, x is 0. And then the other numbers are y-intercept, so you plug in -3 for b. So that's why we have 1/4 x minus 3 for our equation. All right. So I got another set of notes, but anybody holding on to this before we go to the next one? All right. So now we're introducing another formula, the point slope form, or another form, I should say. Y minus y1 equal to m times x minus x1. Where once again, m is our slope, and then x1, y1 is any point on the line or any point generated by the equation. So we're going to use that point slope form to write an equation. So this time we don't necessarily need our y-intercept. We can have any point on a line and be able to write an equation. So we have write an equation of a line that passes up with a slope of 2 and passes through the point -4, 6. So they give us a slope and they give us a point. So over here in the red, I labeled, what they gave us. Of course, our slope is m. That's 2. And then our point, -4, 6, is going to be x1, y1. Here's formula over here. Notice we're plugging in for y1, m, and x1. Y and x should stay a part of your equation. If you remember, when we had our other equations, there was a y and an x involved. It's x1, m, and y1 that we're actually replacing with numbers. So just make sure you're careful there. So you plug in 6 for y1, 2 for m, and then -4 for x1. So make sure you don't lose the negative. And you're in there. First thing we do is distribute the 2, and don't forget negative to negative turns positive. So that'll be y minus 6 equal to 2x plus 8. And then add 6 to both sides. Y is equal to 2x plus 14. All right. Any questions? Any questions before we do another one? All right. Another one, very similar, just different numbers. Write the equation of the line with the slope of -2/3 and runs through the point of 5, 0. So once again, my race is still up. So this is what we have. M is going to be -2/3. Our point x1, y1 is 5, 0. Once again, we're plugging in for these three spots, y1, m, and x1. So y minus 0, 0 is y1, -2/3 m, and then it's x minus 5, because 5 is x1. So y minus 0 is just going to be y, so that's not a big deal there. But we do have to distribute that -2/3 into our parentheses. -2/3 times x is just -2/3 x, so it's not a big deal. But you see over here, I did the work multiplying -2/3 times -5. So just make sure you're careful there. Don't forget your fractional rules of fraction work when you're multiplying fractions. That -5, I wrote it as -5/1, and it's just multiplied across. So on top, we have -2 times -5, which is a +10. 3 times 1 on bottom is a +3. So it's just 10/3 as our y-intercept. Any questions? All right. Another type of problem. This time, notice they give us 2 points. It says write the equation of the line that passes through 3, 4, and 5, -4. They give us 2 points, but they do not give us a slope. So notice I wrote in the red, we need a slope. We have to find a slope first before we can go plugging it into point slope formula or slope intercept form. Notice both of them have slope in the naming of the formula, so we need a slope. So we take our 2 points, label them x1, y1, x2, y2. We talked about doing that before. So I just decided to call the first point I saw, point 1, and that's 3, 4, x1, y1, and then the second point being point 2, x2, y2, 5, -4. And then we use our slope formula, y2 minus y1 over x2 minus x1, to find our slope. So y2 is -4, y1 is 4, and then x2 is 5, x1 is 3. So that will give us -8/2, and that will reduce down to -4. All right. That's on the first part. So now that we have a slope, we can use either point to find a point slope, to find the equation by using the point slope formula. Now, I always normally, whatever I call x1, y1, I just leave that at the point that I plug in. It doesn't matter which point you can use either one, you still get the same answer. As long as you're using the slope of -4 and either one of these points up here, it'll give you the same answer. Once again, I just stuck with what I've already called x1, y1, so I just used the 3, 4. All right, so plugging in -4 for m for our slope, then 4 for y1, 3 for x1. Then distribute that -4. So I have y minus 4 equal to -4x plus 3. So make sure you pay attention to how they want you to put your equation and then their final answer, the form. Now, before we've simplified our answer to slope intercept form, if they ask for standard form, that's what I have going on right here in the purple. Standard form is when you have your x and y term on one side and then the constant, the term that doesn't have a variable, on the other side by itself. So that's what I did here. I just added 4x to both sides. Excuse me. So I added 4x to both sides and then added 4 to both sides so that I have my x term and my y term on one side by itself, and then my term without a variable at all on the other side. So that'll give us 4x plus y equals 16. Yeah. So if they ask for y-intercept form, make sure you solve your equation for y. That's y equal to mx plus b. Or if they ask for a standard form, this is your standard form. Now, if you have it right, but you put it in the wrong form, it should tell you. It should say something like the answer is correct, but it's in the wrong form or something like that. But yep. Make sure we are okay. Any questions? Or we look at the next one. All right. So last class, we talked about parallel lines and perpendicular lines and their relationships with their slopes and everything like that. So we're taking that and going to the next step. It says write the equation of the line that passes through 1, -1 and is parallel to y equal to 2x plus 3. All right. So the line we want to create has the point or runs through the point 1, -1, but is also parallel to the equation of y equal to 2x plus 3. All right. So we know our point, but if it's but we need a slope. So the slope of this line is going to be 2, because remember, if it's already solved for y, whatever's sitting in front of x is your slope. So m is our slope for that line. But if the line is parallel to it, it's going to have the same slope. So a line that's parallel to y equal to 2x plus 3 is going to have the same slope. If that slope is 2 for this equation, then the slope for the equation that's parallel to it is also 2. Now that we have our slope and we were given our point, we can go ahead and use our point slope formula. That's y minus y1 equal to m times x minus x1. Plug in for y1, which is -1. Make sure you don't lose the negative. Plug in for m, that's 2. Plug in for x1, that is +1. All right. So negative to negative turns positive, so that's y plus 1. And then distribute that 2, that's 2x minus 2 on the right side. Then to finish it off, subtract 1 from both sides. So y is equal to 2x minus 3. All right. All right, similar situation, but this time the line is perpendicular to the equation given. So we want a line that passes through the point of -4, 2, and is perpendicular to 2y equal to x plus 7. All right. So first thing we need to do is solve 2y equal to x plus 7 for y, because we want to know what the slope is. So divide both sides by 2. Y is equal to 1/2 x plus 7 over 2. After you solve that equation for y, that will let us know what our slope is. Our slope is 1/2, because that's what's attached to x. Now, if you're talking about a line perpendicular to this line, then the slope will have to be the negative reciprocal. And we talked about that last class where you flip the fraction, use the opposite sign. So my slope is 1/2. So the line that's perpendicular to it will be flipping that and using the negative sign. So that's why we have -2 as our new slope. Make sure we are okay with what was said and what you see. Scrolling up some. So we're not finished. All we have is our new slope, which is -2. Or all we found is our new slope, which is -2. So we're going to use that slope and the point that they gave. They gave us -4, 2 as our point. Use the point slope formula. It's y minus y1 equal to m times x minus x1. And plug in accordingly. So that is 2 for y1, -2 for your m, -4 for x1. Don't forget negative turns positive, so that's going to be -2 times the quantity of x plus 4. Distribute -2. And that'll be y minus 2 equal to -2x minus 8. So add 2 to both sides. And that'll give us y equal to -2x minus 6. So that's slope-intercept form. Now, if you want to put it in standard form, we talked about that. That means you need your x and y term on both sides of the equation. Constant, the term is not attached to a variable to the other side. So all you do is add 2x to both sides, and your standard form will be 2x plus y equal to -6. Any questions? Any questions? You had a few people that came in. Any questions in Zoom? Is everybody okay? And so that's it for 10.5. Got it good before we go to 10.6. All right, anybody still copying? Everybody straight? I'm trying to see something real quick. Okay. All right, so let's go here, 10.6. So 10.6 is functions. You can just write down a title. I have to go to another page, but 10.6 is functions. Last section out of chapter 10. Okay, I got a good place to start. Okay, cool. All right, so let's introduce functions. Start off with the definition of a relation. Relation is just any set of ordered pairs. So an example of that is 1, 2, 3, 4, and 5, 6. Domain is the set of all first components of the ordered pairs. So that's 1, 3, and 5. And your range is the set of all of the second components of your ordered pairs. So that's 2, 4, and 6. So here's a comparison between the domain and range. So your domain's first component, range is second component. Domain will be your X variables, range will be your Y variables. Domain will be your input, range will be your output. Domain is considered independent variable, range is considered your dependent variable. Your domain will always be your horizontal, be on your horizontal axis, your range will be on your vertical axis. All right, can we scroll up? Everybody good? All right. So definition of a function. A function is a relation in which the elements from the domain corresponds to exactly one element in the range. All right, so the next one, well, first example under this, will determine whether each relation is a function. So they give us the ordered pairs of 1, 6, 2, 6, 3, 8, 4, 9. So remember the definition of a function says that each value in your domain goes to exactly one value in your range. Okay, so you need to be able to ask the question, does this value go to exactly one value in the range for each one of your values in your domain? And if you can answer yes for each one of them, then yes, it is a function. And of course, I'll show you one that's not a function, but let's look at this first one. So we have 1, 6, 2, 6, 3, 8, and 4, 9. So you look at each one of the numbers in your domain. I created a mapping here. This is my domain. This is my range. 1, 2, 3, 4 are the values that are in my domain. 6, 8, 9 are the values that are in my range. Okay. You don't have to write 6 twice. So does 1 go to just one value? The answer is yes, it just goes to 6. Does 2 go to just one value? The answer is yes, even if it's the same number as 1 goes to, but the question is, does it go to one value? The answer is yes. 3 goes to one value, 4 goes to one value. Since it's yes for all 4 of these, that means yes, it is a function. All right, questions on that one before we look at another one? All right. So next one. We have 6, 1, 6, 2, 8, 3, 9, 4. Once again, we want to know, is it a function? All right, so once again, you ask yourself, does each value in the domain go to exactly one value in the range? Well, we have 6 goes to 1, and then 6 goes to 2. So since we have no right here, then that means it's not a function. All right. So questions on the difference between the two? When it's a function, when it's not? Okay. So I got a couple general statements that may help you also decide whether you have a function or not. So here, there can be a repeated value in the range, but no value can repeat in the domain. So what I mean by that is when we look at here, I had a 6 being repeated here in the range, and that was a function. But then here, my 6 was repeated in the domain, and that was not a function. So that's one way of looking at it. And then the range can go to more than one value. The domain can only go to one value. So just different ways of looking at the same thing that we established. Questions before I go? Got a few more things in this section, then we'll be done. I'm used to looking over there. All right, so let's go here. Still in 10.6, we're looking at function notation. So y equal to f of x. That's how you say that, f of x. And all this is saying is that y and f of x are the same thing. They're interchangeable. So y equal to 2x plus 1 is the same thing as f of x equal to 2x plus 1. So they will expect you to know that basically when you see f of x, that's function notation, and the other one's not in function notation. but it still means the same thing. It's just that what happens here, when we have function notation, we can have something like find f of 3. And even if it didn't say find in front of it, if you just had the f of 3, you know what you need to do. It's a set of instructions. F of 3 means that I plug 3 into the function f for x and then calculate. So 3 I'm plugging in, and I'm trying to see what I get out when I finish doing my calculation. Over here, I was just emphasizing that if you had g parentheses t's, function notation is g of t. So it's the same flow, it's just that, different variables. So if I want to find f of 3, that means you plug in 3 for x. So that's 2 times 3 plus 1. 2 times 3 is 6. 6 plus 1 is 7. So f of 3 is equal to 7, but also that if I want to rewrite that as information, that's an ordered pair of 3, 7. That means x was 3, y was 7. I plugged in 3, got out 7. Remember, input versus output, domain versus range, x versus y. All right, so here, given that g of x is equal to x squared minus 5x plus 7, find g of 0, then g of negative 2. So g of x is equal to x squared minus 5x plus 7. And a, they want us to find g of 0. So we're plugging in 0 in each place that we see x. So that's 0 squared minus 5 times 0 plus 7. 0 minus 0 plus 7, and that is just 7. So if they wanted to order pair, your order pair would be 0, 7. But when you plug in 0, you get out 7. That's the main thing. Want to make sure we emphasize them. All right. Then g of negative 2, we're going to do the same thing that we did with 0, except with negative 2. So that'd be negative 2 squared minus 5 times negative 2 plus 7. So negative 2 squared is positive 4. Negative 5 times negative 2 is 10. Still got a 7 back there. 4 plus 10 plus 7 is 21. Mhm. So before we do this last one, let me see if they asked you to do this real quick. Give me a second. Hey. That's a function. Give the domain. Okay. Yep. Just wanted to make sure I wasn't giving you guys extra. Okay, so the next one, next exercise, find the domain. So they give us f of x is equal to 1 over x plus 5. So your domain are values that you can plug in, all values that can be used in the equation for x. So notice I wrote these notes here, just trying to put in perspective what it means to look for the domain. So these are all the values that can be used for x in the equation. Or in other words, all the values that can be plugged in. Now, whenever you have a fraction, you don't want 0 in your denominator, it would be considered undefined. So if I plug in anything into this function that will make it 0 in my denominator, then I have a problem. That's a value I cannot use. So it would be easier to look for the values that I cannot use. And that's what I wrote down here in the green. Fraction cannot have 0 in its denominator. So you want to know, when is it 0 in the denominator? So I'll give you a chance to write that down. All right, scroll up. So to find the domain of a rational expression, or in other words, a fraction, you want to set the denominator equal to 0 and solve. All right. So x plus 5 is my denominator. Subtract the 5 from both sides. X is equal to -5. So this is the value that we cannot use. If I were to plug -5 into this denominator, -5 plus 5 is 0. So 0 in my denominator is undefined, so I do not want that. So using -5 is not a good look, not good for us, but everything else can be used. So when I go to set up my domain interval notation, so it'd be -infinity to -5, use parentheses, because I cannot use 5. I can get close as I want to -5, I just cannot use -5. Then I'll go -5 to positive infinity, and that will be our answer. Scrolling up some. All right, so here we have g of x is equal to 3x minus 1. So just like before, you want to ask yourself, are there values of x that you cannot use? Or is there something that I can plug in for x to make the equation undefined? Same thing, but they were talking about with the fractions. With fractions, plus something in your denominator, make it 0 in your denominator, you get undefined. Here, though, there's nothing you can do. It's just a regular equation. There's nothing that you can plug in that will make it undefined or unable to calculate. So you can plug anything into this equation. And since that is the case, our domain is going to be -infinity to infinity. So all that means all values can be used with no problem. All right. Everybody good? Any questions? All right. Last type of problems that we may see. They ask us to find the domain and range. They'll give us a graph and ask us to find the domain and the range. So don't forget domains are your x values. The range are your y values. Your domain, you're going to write them from left to right, smallest to largest. Your range, you will write that from down to up. Once again, smallest to largest. So when we look at this graph, they give us this line with these 2 points on the end. They give us the order pairs. First order pair on the left is -3, -1. On the right, we have 4, 5. So if you're talking about the domain, left to right, the domain goes from -3 to 4. We're looking at both of our x components of our order pairs. So -3 to 4 are both of our x components of our order pairs. Then for our range going down, up, our y value is -1 in that bottom on that lowest point. to positive 5 to our highest point. So that's why our domain is -3, 4, our range is -1, 5. Now we're using brackets because we have closed circles. Closed circle means we use a bracket. If either one of them were open, we use parentheses. So that's why I have right here, bracket with the closed circle, parentheses with the open circle. All right. Make sure you're okay with that first one before we look at the next one. All right. Let's look at another one. Got a parabola. So as far as our domain, whenever you have parabola, domain once again is left to right. Now this parabola is in the U shape and it's going to continue to get wider and wider and wider. Like there's no limit on how wide it will get. Sorry about that. I had no alarm. All right, so there's no limit to how wide it can get. So notice that's why my domain says -infinity to infinity, because it will always continue to get wider and wider. As it goes up, it continues to get wider, wider, and wider. Now, as far as your range, though, it is from the lowest value up to the highest value. So our lowest value is -2. And remember, your range is always based on the y, not the x. So even though we have the ordered pair of 3, -2, the y part of that, the range part is -2, and then it goes up to positive infinity. All right. Questions on that? Questions? Any questions? Good, everybody straight. Okay. So that's it for chapter 10. Remember I told you if you want to get a test in, if you're ready for it, you can always hit Mr. Davis at jldavis@tcc.edu. Always make sure you CC me. So there's another point of record of you sending that email out. So that's vtucker@tcc.edu. Next class, since we covered 2 blocks of content, is going to be an opportunity for you guys to ask questions, like probably just do a free day. Probably won't do anything new next class. Just give you guys an opportunity to ask whatever questions you want to ask. So make sure you take advantage of that. If you don't have any questions, then I guess you don't necessarily have to come. That's all I'm doing. I'm not going to do anything new at all next class. I want to give you guys an opportunity to get in there and get this stuff knocked out. So with that being said, I'll be there, but if nobody shows up in about 15, 20 minutes, and y'all expect me to just sit there and look at my screen or whatever. So if you're here, whether it be in person or you Zoom, I'll be here, and I'll be here to answer any questions. But once again, 20 minutes roll past and I don't see anybody, and I'm assuming everybody good. So if you do come late and you didn't let me know, then I wouldn't know to stay. You know what I mean? Did I hear somebody unmute?
Yeah, I was just going to tell you that I was sitting here. I stepped away to go get a drink for a second.
Oh, no, you're fine. You're fine. I was talking about for Wednesday.
Gotcha.
Yeah. Mm-hmm. No, what were you saying? Next class, not doing anything new, right? But I'll be here to answer any questions for anything. So what we've covered up to this point. Hold on. Yep, last day of class. So we've covered the first block of content. So there's this first test, and we just closed out chapter 10. So I'm trying to create this balance of where we gotta move a certain speed because it's summer, but I'm trying not to overdo it. Yeah. So next class, we're not gonna do anything new. I'll answer whatever questions you guys have. But if, in other words, if you missed next class, you're not missing out. You just, unless you had questions, but you always come to my office hours as well. So those are still there. So, but we're just not going to cover any new content next class. All right. Oh, let me hit that button, but it's all good. Any questions, anybody, before we close out? Anything, anybody? All right. Everybody in Zoom good? Everybody straight?
Yeah, I just have one question.
Hmm?
It's not really on topic with anything on class, but I was going to come in person for like on Wednesday to do the review. Which building are you in on the Portsmouth campus?
It is the A building.
Okay, the A building. Thank you.
Yep.
I appreciate it.
Yep, A111. Yep, A111. Yep.
Okay, cool. Thank you.
No problem. All right, so if you guys are good, I'm good. You guys have a good day, and I will see you on Wednesday.
You have a good one.
How you do the same?